Let's go on now and talk about floats. So floats are what we use to represent real numbers. So we had integers for representing whole numbers, but then we have things like money, we have percentages, we have GPAs. There's all these situations where we want a decimal point. And that's what floats are for. Our float operators work exactly in the same way as our int operators. So I don't have to show those again. And it's also useful to know that you can mix and match the ints and floats. So 2 plus 2 or 5 plus 6, that works for with our integers. You can also do 5, which is an integer, plus 6.1, which is a float because it has a decimal point. And the result will always be a float. So Python will make sure that you don't lose the stuff after the decimal point. Commonly asked question, why is it called a float? Why don't we just call it just a real number? I'm going to punt on this question and say you should take a computer architecture course if you're interested. And if you're a computer science major, you definitely will later on in your curriculum, and you'll learn exactly why it's called a float. It has to do with how the computer actually stores what the bit and byte representation of a float is under the hood. Another common question is about doing float arithmetic and getting a slightly weird number. So let me show you what I mean. Let's say I have a number x equals 0.1, y equals 0.2. So if I print out x and I print out y, it prints 0.1 and 0.2 as we expect. But now, if I print x plus y, you can see it prints out 0.300000004. And so it's slightly off, it's slightly imprecise. 0.1 and 0.2 are very clearly just tenths, 1/10 and 2/10. And so you would expect to get exactly 3/10. But when the computer tries to do that addition, it seems to get a little bit off. So this has to do with how bits and how floats are represented using bits under the hood. It turns out it's actually a really hard problem. And so if you're curious to know more, you can ask in office hours or ask on Piazza. But when we try adding and doing just arithmetic with floats, sometimes we'll be off by a little bit. That's normal and that's okay. You can always round the results because you'll only be off by like something maybe 10 or 15 places after the decimal point. It won't be anything, any major difference. And finally, we have a string type. So we've been using strings so far in this class quite a bit. A string is a sequence of characters, and each character in the string is just a single letter or symbol, like C or an exclamation mark. The way that in Python we can tell that something is a string is that it's in quotations. So that thing on the right there, quotation mark hello, quotation mark, is called a string literal. And it means that the string is taken, those letters are taken literally. Now you should understand why that's important, because here, like on the left, we have X, and on the right, we have hello. And so this is the difference. This is how we tell Python that we mean the actual string hello, the letters HELLO, and not some variable named hello, which is what Python would try to look for if you don't have those quotation marks. And so some of you might have noticed that if you were to try to type, so greeting equals hello, without quotation marks, and you run this code, Python will throw an error and it'll say name is not defined, because without the quotation marks, Python is actually looking for a variable named hello and it can't find one. So the way we tell Python that we're actually talking about a literal string, the literal characters HELLO, is by putting them inside of quotation marks. And by the way, either double or single quotes both work in Python. You just have to be consistent and have single, or double. If we run this code, now it won't cause an error anymore. We can print out greeting. Let's print out hello. What operators can we use with strings? Well, the main ones I'll cover are adding strings and multiplying strings. And so you can add two strings together just using the plus sign. And this is that kind of tricky thing of mentioning that these operators like plus, they behave differently depending on the type. So for integers and floats, adding two numbers is arithmetic. For strings, even if the string is a number, like an 8 or a 7, it'll still add them as strings by concatenating them, putting them together. So we can see here, greeting, hello, comma, and then name equals student. And I can then print out greeting plus name. And this will concatenate together these two strings and print them out just together. You can see, prints hello, comma, student. And the second operator that is new that we haven't used yet is multiplying strings. So you can have a string like ha, and you can make a new string and have it be 3 times this laughing string. And this way you can multiply the same string and have it repeat over and over. And so just like in math, multiplication is repeated addition. Same thing here, is multiplying a string is repeatedly adding that string together. So we can have equals ha, and we can print first just a single laugh, then we could print laugh times 2, and maybe we can try printing laugh times 10. So if we run this, we can see first a regular laugh, a short laugh maybe, then a regular laugh, and then kind of a maniacal laugh with 10 ha's. In the same way that you want to check equality of two integers or floats, you also might want to check the equality of strings and see how they compare. And so you can do that the same way that you did with numbers, with integers and floats, by using the equals equals operator. And so here we can have, name1 equals Alex equals Deontay. And if you compare these, is name1 equal to name2? False, they're not equal. And by the way, you might have noticed this whole time as I do examples, sometimes I'm putting these operators inside of the print statement. Other times, I make a variable first, and then I reference that variable inside of the print statement. Either way works because these operators will get evaluated. The operator with whatever it's comparing is an expression that gets evaluated, and you can either store it into a variable first and then reference that variable, or you can just put it in line and that expression will be evaluated and its result will be given to print. So if I run this, we'll see the same output. But if I change our names to be the same, if name1 is Deontay, name2 is Deontay, now we see true. I'll just point out that this is case sensitive. So if I make lowercase Deontay and uppercase Deontay and I compare these, we'll see that Python will now print out false because the case doesn't match anymore. One last thing I'll show you about strings right now is about the length function. And so the length function is very handy. It'll tell you how many letters are in a string. So I can print out here length of name1. And if I run this code, oops, I can see that the length of name1 is 7 because Deontay has 7 letters in it. Okay,